Hello again. The main motive of this video is to understand how to choose between combination and permutation while solving the problems. We are not focusing on answers here. Permutation. One way is to think of permutations as the number of arrangements, or orderings within a fixed group. As in mutation, change only occur or we make it occur, in specified fixed portion only. All shot of changes or mutations occur at that portion only. For example, if I have 5 students and 5 books, and I want to figure out how many ways I can distribute 5 books, I'm going to use the permutations formula. Firstly, the number in the group is fixed. Secondly, I'm looking for how many ways I can arrange the books to 5 students. For first student I have 5 ways to distribute. And for second student I have 4 ways, as one book I already gave to the first student. Similarly, as shown, this process will go on. Combinations, on the other hand, are useful when figuring out how many groups I can form from a larger number of people. For instance, if I'm a dance teacher and I want to find out how many distinct teams of 3 dancers I can form based on a group of 10 dancers, I will use combinations. As you can see here, we cannot use 021, 031, 032. Because 012, 013, 023 are already in one group. The main thing is to understand is that, where we will use what. Let's understand more with the help of few questions. Deepika has 5 panels at home, that she wants to paint. She has 5 different colored paints and intends to paint each panel a different color. How many different ways can she paint the 5 panels? Just think, for solving this, we have to choose permutation or combination. The answer is permutations. Because she wants to arrange the colors, the number of panels is fixed. Now let's say, what if she had been choosing 5 panels from a total of 8, then we would need to use combinations. Next question. How many unique combinations of the word colloquially can I form by scrambling the letters? Think, for solving this, we have to choose permutation or combination. Answer is permutations. Okay, this was a little bit of a trick since I used the word combinations, but that word I used colloquially, not mathematically. In this case, the number of letters is fixed. We are simply rearranging them. Colloquial is an adjective used in ordinary or familiar conversation, not formal or literary. Of words and expressions, informal and conversational, and more suitable for use in speech than in writing. Colloquial and everyday language. Colloquial phrases. We have to choose permutation or Next question. There are 7 astronauts who are trying out to be part of 3-person in-space flight team. How many different flight teams can be formed? Think, for solving this we have to choose permutation or combination. And the answer is combination. We are choosing a group from a larger group. One way to think of it is that when you use the word choose, in the context of selecting from a group, you are dealing with combinations. And choose and combinations both begin with the letter C. There is an exception to this rule that you will see in next question. Next question. A group of 12 sprinters is competing for the gold medal. During the award ceremony, a gold medal, silver medal, and bronze medal will be awarded. How many different ways can these 3 medals be handed out? Think, for solving this, we have to choose permutation or combination. The answer is permutation. If you are forming a group from a larger group, and the placement within the smaller group is important, then you want to use permutations. Remember that with permutations ordering is key. Even though the top 3 spots for the sprinters forms a subgroup, it is the ordering within that subgroup that matters greatly, and is the difference between a gold, silver, and a bronze medal. First we have to choose for gold. Hence there are 12 ways for distributing gold. After that 11 ways for silver and 10 ways for bronze. The result is as 12 multiply 11 multiply 10 equals 1320. You might notice that this is the fundamental counting principle. The idea that when we are looking for total number of outcomes, we multiply numbers, or in this case, the number that goes on top of the metal podium. For instance, if I have 6 pairs of shorts and 4 pairs of t-shirts and I'm wondering how many different combinations of shorts and t-shirts I can wear, I want to multiply each, not multiply them. 4 multiply 6 equals 24. To give you an idea of how a combination can show up along with the fundamental counting principle. Question: Mrs. Pearson has 4 boys and 5 girls in her class. She is to choose 2 boys and 2 girls to serve on her grading committee. If 1 girl and 1 boy leave before she can make a selection, then how many unique committees can result from the information above? The first step in this problem is recognizing whether we are dealing with combinations or permutations. Since I am choosing from a larger group, in this case 2 separate groups, I want to use combinations. Remember, once we've chosen the 2 boys or 3 girls, the position within the committee doesn't matter. That is, either you are in the committee or out of the committee, there are no gold medalists here. The next thing to notice with this problem is that of the original 9 students, 2 leave, 1 boy and 1 girl. So that leaves us with 3 boys and 4 girls. We want to choose 2 each. Therefore, we have to set up 1 combination for boys and 1 for girls. For boys, we have 3C2 and for girls we have 4C2. This gives us 3C2 equals 3 and 4C2 equals 6. The final step is once we've figured out the combinations above, we have to use the fundamental counting principle and multiply the total number of possibilities in a committee, not add them. 3 multiply 6 equals 18, answer, C. There are 2 rules of counting for addition, OR, or rule, and for multiplication, AND, and rule. For example, suppose we have 2 pens and 3 markers. And we have to choose 1 object. In how many ways we can choose? We can choose red pen or blue marker or yellow marker or green marker. That means, we have 2 pen ways and 3 marker ways equals 5 all ways. As you see, we use OR for addition. Now suppose we have to choose 1 pen and 1 marker from these 5 objects. Then how we will choose it? We can choose red pen with any of the 3 markers, or similarly blue pen with any of the 3 markers. Which will give us 2 pens way and 3 markers way, resulting 6 total ways. As you see, we use AND for multiplication. Let's see one last example to clarify more. Suppose you have 3 keyboards and 3 mice. In how many ways you can select 1 keyboard and 1 mouse? There are 2 ways you can count. First way is to add 1 by 1 every pair. That is by OR method. Second way is to multiply 3 keyboards way and 3 mice way. That is by AND method. Thanks for watching, please like and subscribe.